crustacean that grows in fresh water that serves as the intermediate host for the disease. And when humans ingest water that has an infected cyclops, which is the name of the intermediate host, they will acquire this disease.
It's a worm that's about twice the length of a yardstick in some cases. It lives in your subcutaneous tissues, and it seeks out the lowest part of your body. And there, the head of the worm elicits a blister. It's a visible blister. You can actually see the head of this worm under the blister. When you step in the water, the blister bursts open, releasing larvae that the worm has produced into the water column. And then you get to see this ugly, disfiguring blister on the end of your foot, which you now have to do something about. And in most countries, what you do is you grab a small stick and the head of the worm, wrap the head of the worm around this stick, and slowly, every day, turn the stick, slowly pulling the worm out from your skin. If it should break, you will experience the worst anaphylactic reaction you can possibly imagine. You'll get a sloughing of skin in the region where the worm is. It will become secondarily infected with bacteria, and when it heals, you'll have a nasty scar for the rest of your life.
This is as real as it gets. Discovery's Sunday Showcase, only on Discovery Channel. Another bloodthirsty parasite that burrows through our skin is the schistosome. The schistosome is endemic in parts of Asia and Africa and utilizes a snail as an intermediate host before infecting humans. Juvenile schistosomes, called cercaria, emerge from their snail host into fresh water, where they swim frantically looking for the complete development, a human. Once the swimming cercaria find human skin, they eject their tail and utilize skin-dissolving enzymes to burrow through the skin of the foot and eventually into the bloodstream.
One of its remarkable ability is its capacity to live in what should be the most inhospitable place on Earth, an individual's bloodstream. These worms actually live in blood vessels. Now think of it. If you were an infectious agent, where's the last place you would want to set up shop? Where you're being bombarded daily by antibodies, being bombarded daily by white blood cells, and yet here the schistosome not only survives, but it thrives.
Once the juveniles have matured, the male and females pair up for life, where they mate, continuously producing and releasing eggs.
Let's take the example of the bladder schistosome, known as schistosoma hematobium. With this type of schistosomiasis, the egg has the ability to traverse through the bladder wall. As the egg does this, it elicits a host inflammatory response that's also associated with bleeding. As a result, people who harbor bladder schistosomes develop blood in their urine, a condition known as hematuria. A curious instance where the presence of hematuria caused by bladder schistosomes affected history was when Napoleon entered Egypt. Napoleon's troops, it was prophesied, would be stricken by Pharaoh's curse should they choose to enter into Egypt. And what was Pharaoh's curse? It was male menstruation. And sure enough, when many of his troops came into Egypt, they acquired bladder schistosomiasis, and many of the troops believed that this was the prophecy of Pharaoh's curse fulfilled.
Another fascinating parasitic disease is one called onchocerciasis, the common name of which is river blindness. This is a parasitic disease caused by a roundworm parasite of man that in its clinical end stages causes a very devastating and irreversible blinding disease. It's a parasite that is transmitted from human to human by the bite of a black fly, which is the vector. The black fly breeds in fast-flowing streams, and therefore the disease is most endemic in the valleys of these streams, and thus the name river blindness. After the vector bites a human, it deposits the larval worms which invade the skin and eventually end up forming a nodule under the skin where the adult worms develop. While they're in this fibrous nodule under the skin, the adult worms shed on the order of 3,000 to 5,000 microfilariae, or larval worms, per day per adult. These larval worms, instead of entering the bloodstream, remain in the subcutaneous tissue and migrate through the subcutaneous tissue, causing changes to the skin that can manifest in such ways as very hypoelastic skin, baggy skin. As the disease progresses and the number of larval worms in the subcutaneous tissue increase, they eventually gain access to the tissues of the eye and cause microcalcifications, which over time build up and cause the blindness.